In a previous video, we talked about how to set up a linear programming problem. In this video, we're going to continue where we left off. Alright, so here's our setup from the English to the math. So now we'll go into graphing the feasible region. I already have my axis set up. There's my linear programming problem. So let's just go into graphing it. Now, since I've already covered in other videos how to graph a system of inequalities, I'm just going to go into graphing the lines and then sketching in the feasible region. If you do not like what I did, I would suggest that you review those videos, and actually later on I will ask that you review substitution and elimination in a different video. So for our first one, 2x plus 1y is less than or equal to 16, we'll have an x-intercept at 8 and a y-intercept at 16. Sketching that line, and this is the line 2x plus y equals 16. And again, I'm just drawing in the final feasible region, so I'm not going to do the intermediate shading. So please review those other videos. Here, notice we'll have an x-intercept at 11 and a y-intercept of 5.5. And then we'll draw that line in. This is the line x plus 2y equals 11. And our last one will be x plus 3y equals 15. X-intercept is 15, y-intercept is 5. And sketching this line in. I think it's pretty good. And again, this is the line x plus 3y equals 15. Very good. Our final feasible region will turn out to be this section right here. Let me sketch that in real quick. As stated before, your feasible region, your final answer, cannot cross a boundary line. So make sure you do not include this triangular region, this one, or even this one in your final answer. Our feasible region has 5 corner points. Some of them are nice. Notice we have this corner point. That turns out to be 0, 0. We have this one right here, 0, 5. We have this one, 8, 0. Now if they happen to land on the y or x axis, then you really don't have much work to do. You just point to it, say, okay, it's a corner point. Anything that is not on the x or y axis, you're going to have to use the elimination or substitution method to figure out where that point came from. So again, if those methods are icky for you, icky is a technical term, go back and watch that video for elimination or substitution. Notice we have another corner point right here. To figure out what lines make up that point, this is where it's essential that you label them. Notice this is the red and black line making this corner point. So you would use elimination or substitution on the equations x plus 2y equals 11 and x plus 3y equals 15. If you were to do that, you would get the ordered pair 3, 4. Similarly, notice this corner point comes from the blue and the black line. So you would use elimination and substitution on 2x plus y equals 16 and x plus 2y equals 11. If you did, you'd get the point 7, 2. What you want to avoid is looking at it and saying, oh, that looks like 7, 2, that must be the point. Well, that's only true if you drew your lines correctly. If it turns out that the corner point is fractional, if it turns out that your corner point has a decimal coordinate, then you're in trouble. You won't be able to look at the graph. So whenever it's out here in the first quadrant, please use elimination or substitution. Do not rely on what it appears to be close to. To finish out the corner point method, now that we have our corner points listed, we're going to make a little chart. Remember, this is x comma y. Always, always. Actually, that is one of the most common mistakes while doing the corner point method. Students have been known to switch their coordinates, and that changes the whole problem. So please be careful with that. And then next to this, we'll write our objective function, z equals 3x plus 5y. And now we put in these coordinates. We'll put in 0 in for x and 0 in for y. So we'll have 3 times 0 plus 5 times 0 is 0. We'll do the same thing for 0, 5. 3 times 0 is 0. 5 times 5 is 25. At 8, 0. 3 times 8 is 24. Plus 0 more is still 24. At 3, 4. 3 times 3 is 9. Plus 4 times 5 is 20. So this gives us 29. And lastly, 3 times 7 is 21. Plus 5 times 2 is 10, which is 31. Now let's go back to the objective function we're trying to maximize. And notice we did that right here. 7, 2 is called the optimal solution. And 31 is the optimal value. So what does that mean for this problem? That means that Carla should make 7 garden mix packages and 2 potting mix packages. And the 31 means is she'll bring in $31 in revenue